Uh, so let's start the session. It's already 9 now. Just a brief introduction. My name is Imtiaz Sajid and I'm working with APNIC as a network analyst and trainer as well. So this session is about the introduction to network automation. Since it's just one session, so we will be just having the presentation session without any lab. Normally we tend to do the lab because it's hard to understand things without doing them practically. But due to the shortage of time, unfortunately, we will not be able to do in this session. But I will be able to show some of the lab steps, like how you can install and see different commands we execute and their output as well as we proceed through the presentation. So this is the link for the course material. So what I'm presenting, it's available on this link. So if you need, you can download from here. Otherwise, you can go to APNIC Academy and there it will show under events this event, the network automation session, and the complete detail is also available there. So what I'm referring is, I'm referring to this page. If you go to the APNIC Academy, there you have the events. You click on the upcoming events and then it displays the list of events. From there, if I go back, so you can see here Introduction to Network Automation APAN59. If I click on this link, then it will load the course material page. You can click the it will show the course overview by default, but you can click on the course material to get the complete detail. And yeah, if you scroll down, so we have only one session, and then you have some additional resources as well. I will later on let you know about these resources as well. But if you just need the slides, you can click on this presentation link and it will open up the slide in a PDF format for you. So this is same what I'm going to present. Okay, so let's move on. So we just the first thing is like, what are the three W's for the automation? So the automation is actually the use of machines or computer that can operate without the need of human control. This is like generic definition we can have for the automation, but actually the automation purpose is to create the applications and technologies to produce and deliver goods and services with minimum human interaction, because obviously in an human environment we cannot have 100% automation. Then in case machines will get the control, we need to provide the input, and based on that we want to do the application or services to do things on our behalf, and this actually help us to improve the efficiency and reliability of different things, and we can do the things in a speedy manner, and they because the machine can act quickly than the human beings, so this help us to improve the performance in terms of speed as well. So sometimes people think the automation means replacing of the one manual command on a device with another command. That's not truly understood in a right way. And another confusion could be like, we can think of just the configuration management, because configuration management is just one part of the automation, it's not the whole part. there are tools available which you can use just to do the configuration management if you just need to do that. Uh, Another like in this case, our goal is to actually design a system which is capable to self heal itself, and it can give us a data when there is some issue is happening or some service is going down. So based on that, we can later on we can have a report, and it can try to repair itself, and that data is actually going to help us to investigate the issue if the logs are available. Why we need to automate? So as a network engineers or system engineers, uh, we actually spend a lot of time to do very boring things which we should not be doing, and we should be doing spending time on some difficult tasks which like machines cannot do. And we need to have stable networks, because in case the humans they keep on changing the networks, then it can risk we can have a risk of an outage or maybe some problem we can create. So the system actually help us to fix the things in a better way, and we it can also help to create more reliable networks in like in terms of we can say uh, the reliability will come because there will be a systematic approach, and system can even test the new changes before applying, because sometimes a human can make a mistake and we think okay what we are doing is okay, maybe someone else need to review those changes and then need to be implemented. So in case of system they can use the unit testing, and this actually help to find out the different problems within the software or within the commands we are going to apply. So automation is like help us to audit the changes as well, because when the changes are going to be done there would be logs, and these actually help us to have some sort of compliance as well. If we have a requirement to get some certificates or iOS certificates too, based on the compliance. Uh, in case we are doing changes, we need peer review. So whatever I'm going to do, the others, there should be someone else who can review those changes, and then actually it should be applied, which automation can help us. And we can have like the continuous integration and continuous deployment, which can help us to find the issues before we actually deploy the new changes and deploy new system or new application within our network. We can have the history of action which are done over the course of time, and we can later on see those changes if there is some event, or we can correlate them. Okay, at certain point these changes were done and this event has happened, so is there any correlation between them, any link like they have caused this incident was caused by these changes. Who should automate? Anyone who want to start it, it's would be the right time when you think like you need to do, and you do not need to learn the code, because if you have some knowledge that's good, but if you do not have, still you can do. And we should not wait like to have some of the like best tool for ourselves, because the tools are built over the course of time and they could be improved as well. So we have to select from one of the existing tools which are available and see which one is can fulfill the need in our case. So how we can choose the tool? See, this depends on the number of different factors, like how large is your network. Maybe you can think about the scalability, how diverse are the different platforms in your network, and how frequently the changes is happening, and do you need the event driven automation as well. So if your network needs to respond to events in a real time, and you are looking some tools which can actually support this idea. So so we have based on like what we discuss, one of the like tool available is the salt, and there are other tools available as well, like Ansible. And but why we want to choose the salt? So one of the reason is like the event driven automation and orchestration. So this actually help the large networks who can want to scale, and it can have like the flexibility to abstract any support of the unlimited different mix of vendors hardware as well. So you can have asynchronous changes as well, because now you need to apply the changes through the different commands simultaneously on your network. So salt can help to do that. And it have like native integration. It can work seamlessly with hundreds of different products and services, and you can configure your setup according to your need as well. So why people choose salt is based on the it's built on event driven automation, because in case of Ansible, that is not by default available, and you need some additional tools actually to enable that. So this is the one of the key features. The another thing is, in case of salt, it's agent based and Ansible is agentless. So maybe if in your case you are thinking to have just want to run some commands, and you do not have the support to or do not think about having agents, then maybe you can use the Ansible. But over the it has the flexibility, like you can execute number of commands simultaneously, and then the salt itself within the architecture, we will talk later on, like we have salt minions which actually help you to execute those commands. Even you have some latency within your network, they can keep on executing and then give you back the result. But in case of Ansible, you are doing the SSH to the device and then executing the commands. So if you have a small network, then maybe the Ansible could be the solution for you, because in terms of learning, that is more easy. But Salt is like for the large networks who want to use the automation in case of any events are happening, and you are not worried about like you can afford to have the agents as well, because in some of the environment there is a concern about the security, and in that case you do not want to have the so many SSH going on, and you just want to rely on the salt in this case. So just a brief introduction to salt. In salt, it is said the speed is not the byproduct; it is design goal. And the salt was created as a extremely fast, lightweight communication bus to provide the foundation for a remote execution engine. Salt now provides orchestration, configuration management, even reactors, cloud provisioning, and more, all built around the Salt high speed communication bus. So if we talk about the architecture, it is an hub and spoke model where we have the Salt master and minions. So master is our main application in this case which actually talk with the minions. So minions are the agents which actually gets commands from the master, and then minion try to execute those commands and give the feedback to the master as well. So there could be more than one master depending on the network. If you have a large network, maybe you like one master can support up to 10,000 minions. If you have more than that, maybe you can think about having multiple minions, or maybe you can tweak your configuration as well. So in salt architecture, as I said, we have a minion and master. So minion is also a process or a system services which actually help us to manage the machine, and it is installed on the device itself. So it has the advantage to execute everything locally, because in case of Ansible you have to establish a SSH session. In this case, your session is going to be established from the master to the minion, and that's the secure session, and then minion actually execute the commands and give feedback to the master. So master is also a process which is running on a dedicated machine, and it could be like one master can manage up to 35 to 40,000 minions as well. So this is like you can use a VM to install the master. You can use the same VM to install the minion as well. So in case you need every device actually need one minion. So one minion will be per device in your network. So master and minion, they actually build a communication channel over the using the encrypted channel using the port 4505 and 4506, and this uses a public and private key pairing. So the minion listen to the command request over the port 4505 and send back the execution result to the master over the port 4506. So that means the minion need to listen on 4506 and master need to listen on 4506. Sorry, 4505 will be the minion and 4506 will be the master. So when minion will start up, the process will start. It will try to connect with the master, and it will provide its public key to the master, and then based on that the master is actually able to recognize the minion, like its public key already existing with the master or not, and then it will be able to accept or reject its request. So when we install the minion, we actually send the key to the master. So master already had the key for the minion before it start the communication with the master. So this actually help us to have like beef up the security, and if someone is sending any request from a minion which is, does not have the key with the master, so it is unable to communicate with it. So in case of, there are some naming convention like options. The configuration option are provided by the user in master and minion configuration file, and usually they are referred to like in a certain location. We can see here in case of master need to read from etc salt/master, and minion need to read from etc salt.master. So these are the location where the we have the file, and we actually we can change the setting there based on different options available. Another naming convention which is used in case of salt is pillar. So the pillar is the data which is given by the user, and this actually is used to later on use for to model the automation logic, and this actually represent like this is used to represent data as well. So the example could be the interface, and their IP addresses are the list of prefixes. We have another naming convention which you will keep on hearing is the grain. So grain is actually the data which is collected by salt dynamically, and this actually represent the attribute about a device which we are managing. So in this case, we actually get the data about the system, like its model number, vendor serial number, CPU model, etc. So we know what is the device that we are going to manage, and then we can select the specific module for it accordingly. So in general, you do not need to do anything about it. It's just like about the their existence. And the grain, they can be used to like model automation logic based on the different attributes, like we take care during the deployment as well, like which platform we need to deploy, what could be what is the software needed, because once we have this information, then we can use it later on. So grains can also provide statically or from the external sources, as some of the attribute can be they can be retrieved from the system itself. So we can say, in short, we have pillars, which is the automation data, and grains are the attribute of this data. So as we said earlier, like in case of salt, we have master and minion. So a salt minion is actually a service running on a machine or system we want to manage. So this could be your network device, or it could be any server as well. So if you cannot install the salt minion on a device, then you can use the proxy minion, because there are devices, especially the network devices, where you cannot install the agent. So in that case, you can have the proxy minion, and this proxy minion, it can talk to the device using the we have the HTTP, netconf, SSH, and GPRC. So these are different protocol it can use to communicate with the device, and then execute the command and get back the feedback and share with the master as well. So this is how it look like. So we have master, we have proxy minion, and we have the device. So master talks with the proxy minion. Proxy minion, it can talk with the device using different protocols. We have here HTTP, SSH, and the netconf. Why we need this? Because the some of the devices, it's hard to actually install any agents. Like you may have some legacy devices or some vendor specific devices where they do not actually allow or even give you the root access. Because I came with the similar problem. We were having the SD-WAN from a vendor, and they gave us the CPs, and now the root access is with the vendor, and we just have the read only. If we are asking him, okay, please enable the SNMP, we want to monitor, he's saying no, you have to go through the API, and you have to go to the director. Actually, in case of SD-WAN, you have a controller and director. So it was becoming hard for us to monitor, because we were not prepared to have API support in our NMS and use it. It was quite new to us. So then we have to use a NMS which was providing the agentless monitoring, like using the SSH. So you can have similar use cases in your network where actually you cannot install the agent on the device, and you can only communicate through SSH or maybe through netconf as well. So the proxy minion, they are, as I said earlier, they are simple process, and they can be run anywhere as long as you have the you can fulfill the following condition. It can connect with the master and can connect with the device. So as you saw earlier, it has two sides. One is going back to the master or receiving from the master, another is going to the device. So as long as this process can communicate with the both of them, you can have it. So for every network device, you will have a proxy minion. So one proxy minion per device. So you can think about how many devices you have in your network. So that number of proxy minion you will require if you are going to install or use it. So in deployment examples, like we can be running proxy minion as system services on a single server, or we can use the to distribute over the multiple service. We can use the Docker containers, and those could be managed by the Kubernetes as well, and we can run the service in the cloud as well. So there are like different ways to do this, because it's just a process. So if you can manage to have multiple processes on the same system, you can have. Otherwise you can use the Docker container, because in that case it's just an application, and you can use that and easily manage it. So how you can install it? This is the command. Like you can just execute this command on your Linux server, and then you would be able to install the master. And if you need to install the minion on the same, you can install the minion as well. So if you will click on this link, it will take you to the GitHub repository we have from the APNIC, and there we have the complete list of commands to actually help you to install the master and minion. Let me open this. So if you will click on the link, you will be able to go to the lab 1, and there you can see we have the installing salt.md, the markdown language, and there we have given the commands, and there is some text as well to help you to understand if you are doing it first time. So this is how you will be installing the salt. You need to import the key, and then you need to add the key as you need to add the repository for this, and then you need to update your system, and after that you can use this command to install the master. Because if you try to directly install it without updating your system, it will not be able to locate the package. Similarly, you can install the minion as well. And if you need to check like what is the version, you can use the salt master -v, similar to like other packages we installed, and check the version. So then it will tell you like what are the different details about this software as well. So the next thing we are going to talk about is the introduction of YML and Jinja, because these two are actually used to build the templates in case of salt. So those templates are later on used to manage the devices. So in case of YAML, as you know, it's yet another machine learning language. So in this case, the salt actually define their configuration structure within the YAML, and this could be like using the states and the pillars, and it would be in a human readable format. But the Jinja this actually help us to add the dynamic logic like loops, variable. So what is not available in the YAML, that actually we will use the Jinja to help us to come up with the deficiency, and together these two help us to define the template. So there are 3 rules when we have the YAML file. So the first thing is, like you can see, it is actually you can have a colon, and then you can specify what is the value for a different data. So for example, we need to declare the location, so we use location, and then we use the colon, and then provide the value. So similarly, like colon, they are used in YAML to represent hash and associated arrays. Like it could be one-to-one mapping between a key value and key and its value. So in this case, we have the like the interface, and the value against is etc, et-0-0/0. This is the interface we have, or we can tell like do we need to enable or disable the interface. So interface is equal to enabled. So we will use colon, and after that we will provide the value. Second rule is like how we put the spaces in the file. So it will have it. We do not use the tab. We just use two spaces. So this is like the our interface. So after that we will use two spaces, and then we will write the name of the interface, and after that another property we need. So we will keep on having two spaces after this if it's falling within the same hierarchy. So again, using the rule 2, we have like the different interfaces. So this is the first interface. Then we are saying enable. So we have kept two spaces it ahead of its interface, and then provided its value. The next interface, again two spaces. Next interface, two spaces. So you can maybe notice like the interface and then two spaces is coming after the interface name. But whatever the interface property, that's falling under the interface. So the third rule is like we use the dash and hyphen to represent the list of items, and like here we have example NTP server. If we need to provide multiple NTP server for the configuration, so this is how we can do that. We have the NTP server, and then we use the dash to provide the value. So this could be a list of items in this case. So this is an example of YAML. I will just move on. So in case we need to use in the YAML like some of the characters, so we can use the like true, false, yes or no, or on, off. So then we need to think out what and how to represent them or how to put them. So like we can provide enable and then true, enable, then on and off. But if we are going to use the text, then we need to put it around the quotations. So YAML is simple, but there are some like gotcha characters. So if we need to use like provide multiple text, then you need to use the pipe sign, because this will tell the file okay we have multiple lines coming down. Similarly, like in case of Linux, if we need to break the command, we put like backslash and then write it on the next line. And again we need to remember like there will be two spaces in indentation in this case as well. So this is again the example. In this case we have an interface, and then we have a list or name, and we are providing the interface name like in case of text, and then we need to put the quotations. And if we just want to give the status like enable, true or false, we can give it. And then description, again description will be some text, so we need to put the quotes around it. The MAC address, it's just also a string, so we also need to put the quotations against it. So there are three rules for the Jinja as well, because the Jinja is again the template language, which is actually it's a way to interact with the system, and it could be like complex as well, but we have to like start from somewhere, and we have to learn about it if we want to use this system. So let's see what are the different rules in that case we have. So in this case the rule 1 is to use the double curly braces. This means this is a variable and you need to replace it. So whenever you are going to have a variable, you need to put against the double curly braces, because in some cases you put like a percentage sign before variable or maybe dollar sign, but in this case we have the curly braces. And when we need to input data, we need to provide in quotes, and the result will be like this: interface is GE 0/0/0. So the rule 3 is the conditional testing. So in this case, if we need to do the conditional testing, this is how we can do. Like we can use the double equal sign, and then it can compare the value in the both side. Like this interface name is a variable, and on other side we have the interface itself string, and it can compare them. So if this is they are equal, whatever we have passed here to the variable, then it will execute this line, or it will output this, give us this output. The interface is 10 gig. But if else if this is so this is how we write the else if, elif, and interface again the variable, and then if interface is GE, then it should print the interface is gigabit Ethernet. We can have else, and then at the end we need to end it with end if. So in the previous case we saw, like if the interface name it would be G0, then it will have the following output: the interface is gigabit Ethernet 0. So how we can use the loops in this case? So we can use like for instruction for the loop, like we can have bracket and percent sign and for, and then the variable, and then the array from where we are looking into it, and then we can loop through it. So it will check the interface variable and then the interface name here, and after that, like you can, if you need to do some operation on multiple interfaces or multiple devices, so it can check each of the device within that list and then execute what is the command needs to be executed. So this is just simple, like in other language we have also have the loops, and same is the case here as well. So the third rule is, like in case of loop we can continue if we want to input the multiple data, like we can have interfaces, and then we can use the dash, and we can give the list of interfaces to the input, and then the our resulting result could be like similar to this. So if we talk about the previous example for loop, if we have given there, and it is checking through for loop and then checking the if condition against it, so it will be able to print this: the interface is 10 gig, because based on the value we have given here, it will be able to give us. And if we want to like unshart these interfaces, so we can give the list of interfaces, and then it can execute those commands. So this is similar how human beings do, like we go to the individual interfaces, then do no shart, no shart, no shart. Similarly here we can just pass on the list of interfaces, and then we can just pass one command. So even that same command could be executed over the 100 of interfaces. So in case of salt, we say SLS. So SLS is the specific format. It is by default the combination of YAML and Jinja, and this actually template it's render the Jinja as well, and then the resulting document, it could be interpreted as YAML.SLS, which is called the salt stake state. So SLS is the format which is actually in this case it's used. So how the pure YAML will look like: we have the list of interfaces, and then we can have the interface, and we can have a loop which can actually go through it and read through different interfaces there. So aside from Jinja, salt can also be it can also have the template using other like template engines which are available here, and even you can use the Python as well. Similarly, instead of YAML, there are other ways to represent the data, and maybe you like the JSON, maybe you like the HJSON as well, and you can have like even pure Python to actually represent the data. And then the salt can interpret the SLL file using any combination of these tools, and we can write the instruction. So this is an example how you can use different combination like Jinja and YAML. So your file will look like this, and in case you have the Mako and JSON, then it will be in this format. So you have to specify here with hash with the number sign, and then specify what is the combination that you are going to use. But if you do not specify, then it actually by default using Jinja and YAML. So that is the explicitly it actually think about like you have if you do not specify anything. So if you write something like that, so it is assumed it is in Jinja and YAML. So we can write even the files in pure like Python as well. So in that case, like you specify the number sign, and then you specify this file belongs to the Python, and then interpret can understand about it. We can define some function which actually return some value, and we can have different commands within it. So as the pure Python format, it could be complex, and maybe everyone does not understand. You have to learn about it, but there are different libraries which you can import, and this makes our life easier. So we only need to do minor changes in that case, and it can return some data based on if we use those functions. So in next case, we are going to see how we can configure the salt minion, so it can then interact with the salt master. So let's go to this link. So in order to configure the salt minion, so once you have installed the salt minion, then you need to actually start it as it can start, and but there are different number of ways, like there are many options that you can configure to have a better performance and better control over it. And in that case you can actually tune it according to your environment. So in this case, the most important configuration that is needed to specify the master or the to tell the minion where is your master. So you can mention this using the IP address or the host name. So you within the etc salt minion, actually you specify what is your master, and then the minion actually try to communicate with the master, because other than that it cannot know where is my master is. So you go to the etc salt minion file, and there you actually specify this information. Like by default it will be master and salt, but you can specify master, and then if it is the same VM, then you can specify localhost. Otherwise, if it's a different one, then you can specify the IP address of the master as well. And after that you can run the salt minion in the debug mode, and you can see the output that is being received there. If you want to run it as a daemon, then you can use the -d, and it will run as a daemon in the background as well. So each of the minion, it has a unique ID which is actually help us to later on to communicate and use it with the devices. So in that case we can extract this ID like using this command minion ID, and then we can specify there. How we configure the salt master? So again, once you have installed it, you can run it using the salt master, and if you need to run in debug mode, then this is the command. So as we have discussed, so it needs to actually accept the keys from the minions. So in that case you can use this command to accept the key, and then you can specify the key which you need to accept and which you need to not accept it, because this is a manual way. So here comes the more control over it. Like you cannot compromise this part, because now you actually manually authenticate each of the minion with the master. So master knows what are the different minions that are going to interact with it. So based on this key, actually they are able to decide it. So as we saw earlier, based on the output, we can see the key could be accepted or it could be rejected as well. So here we have the example, like the following keys, they are going to be accepted. We have salt key -y and then we specify the group. So the key for the minion group 00, it will be accepted in this case. So once you have the have running master and minion and the key has been accepted, then we can see that minion is running and usable. So how we can check the connectivity between them? So we can give the command like salt and then the name of the group and then test-ping. So this is how the salt actually just try to oh sorry. I thought it's showing. Sorry, it was my mistake. I did not look at the screen. I was looking on my screen, and it is showing me the output. So I was talking about like how you can configure the salt minion so it can interact with the salt master. So in that case, you actually need to tell the minion where is your master. So where we specify, we go to etc salt minion. There you specify the IP address for the master. So if I just scroll down, so you can see here by default it is this line will be commented. That means it's disabled. So you will specify master and then the local host. In case you have the same host where you have the master, the minion is there as well. But if it's not, then you need to specify the IP address or its host name so it can resolve it. But if it cannot resolve the master, then minion cannot start itself, it will fail. After that, you can start the process in the debug mode, and to run as a daemon you can use the -d switch. We can see its minion ID. What is its ID? Because later on this is actually used when we are executing the command. And we can also configure the salt master as well if we need to change something. Like one of the thing is, like I earlier said, is the key. So the salt master need to accept the keys from the minion first time. So later on when minion is going to start, it actually try to interact with the master. So if the master accepts its keys, then it can start the communication. Otherwise it cannot start, because you need this key to whatever the data has been encrypted by the minion. Now the master need to decrypt, and in that case, if the key is not there, it will not be able to decrypt the commands, and the secure communication cannot happen. So once you have done this, then you can check the connectivity between the minion and master. So this is a way, just like we do the ping for the devices. Similarly, we do the ping for the from the salt master towards the minion. So it can give us the indication, okay, the minion is ready or not. So another thing, like we discussed earlier, is the like the pillar roots. In that case, this is the data that we have for the for our root in this case, and this is how we can manage it. We can specify the path and the pillar and directories, and then according to our environment we can specify it. So each one of them actually is going to have this in the root -conf file as well. If you need to grab it, you can like just grab the 4 lines and it will display it accordingly. Similarly, we can run the master in the debug mode and it will show us the output. If any error or something is happening, we can see it. We have another thing like the top files. So in case of salt, these top LSS, they are found like one of the environment path. For example, we have the above configuration in case of server salt pillar, and under that we have this base directory where we have the salt pillar roots, and this is actually required for these files for the top SLS. So when we are going to do, we first need to make the directory and then we need to specify what are the different groups like which we are going to have in this case. Again, this is the like how you will create your top SLS file, and then you need to populate it. So once you have done this, then you can actually execute the command like salt minion ID. This is the minion ID we discussed earlier, and then the pillar items. So then it will give us the information about the devices within this group as well. So let's go back to the presentation. So unfortunately, due to the time, we are unable to do the lab here. We can just discuss it. That's why I want to go through it. So how we can use the salt proxy minion? So we have NAPAM, which is actually network automation and programmability abstraction layer with the multiple vendor support. So that's mean this is the this is an open source Python library that actually provide us the ability to interact with different devices from different vendors, and using the NAPAM actually we can interact with them, and this actually help us to interact with devices and collect the information from there as well. So again, we can actually do what we can do with using the NAPAM. We can configure and we can replace the running configuration as well. We can do the configuration merge, and we can compare as well. So that means if we need to replace some configuration or we want to check what is the difference between existing and changes, so NAPAM actually in that case will help us. It can actually discard, it can have like a candidate configuration, that's mean without like what is the current configuration running, and then it can commit the configuration without actually committing on the device itself, and it can have another step like staging the configuration, and which will help to actually identify if there is any errors before the actual implementation, and we can roll back the configuration. So actually now most of the devices has this concept of like doing the configuration in two steps. First you do the configuration, then you actually check either there is any error or conflict within the existing configuration, and then you actually commit the configuration. So similar the concept is here. It actually help us to do this configuration in two stages. Even the devices will not help, but it can have its own way of actually testing the configuration based on the existing configuration, and then it can give us the information, okay, if there is any way like if there are any errors, but if we want to roll back, we can roll back the configuration as well. So these are the different supported modules we have. In case of NAPAM, we have the connection management, we have the device information retrieval as well. So we use these of the different modules. In case we need to get the information regarding the interfaces on the device, we use the get interface. If you need to know about the IP addresses, then we use the get interface IP as well. This is again the list of the methods we have. And in case of configuration management, we can like get config. This can help us to retrieve the existing configuration, and we can use like load merge candidate or load replace, compare config, commit config, and discard config and rollback as well. Similarly, we have also the support for operational command, like we can use the CLI methods. So actually this help us to execute command which we cannot run other ways and they are not available. We can use like ping and trace route as well. So in terms of vendor support, what are the different methods supported by different vendors and devices on different platforms? So we can see here we have iOS, iOS XR, EOS, and Junos, and NXOS and NXOS. So these are the different, you can see where we have the green. So there it's supported, and where we have the cross, those are not supported with the specific vendor. So how we can install it? We can do the installation using the pip install napalm. So then it actually it will install the package on the Linux. So in order to use the napalm like a CLI tool, we can easily execute these commands. Like we can specify the keyword napalm and then specify user, password, what is the vendor, like the device we are going to communicate, and so it will be like the vendor, the Junos or Cisco's, then the name of the device, and then we can like get facts to collect the different information about this device. Again, the more detail is available within the configuration guide we have on the GitHub. So the next thing is introducing the Junos Pies, and this is actually Junos Python library which is maintained by Juniper to provide the API to interact with the Juniper devices specifically. So it is similar to like NetMiko. Like in case of NetMiko, we want to interact with the device and through CLI. So similar, we have the concept here. And Junos Pies is actually does not provide a similar CLI feature as we get through the NetMiko, and it is designed to be more used like a Python program. So in case you have Junos only devices or some of the Junos devices, then you can use it. So how the file can look like in that case? So we have from Juniper, this is the format how we like import it, and then we can specify the device and host like VMXL. We can specify username and password, and then we want to have device facts. So then it actually give us the facts. Like if you are using the like the control plane in it, so it will give you the routing engine, like routing engine 0 is acting as a master, and the other one could be your maybe its backup, and you can get the model, you can get the model info and serial number and version and other details as well. Similarly, we have the guide available on the GitHub, like how you can configure Junos proxy minion as well. So there is a link available. So I would leave it to you. You can check it at your time. So the next is the NetMiko. So it's again an open source Python library which actually help us to simplify the management of network devices using the SSH connections, and it is able to handle the connection between different devices, and this is again supported for the different vendors and devices as well. So where the napalm actually is unable to help us to communicate, we can use the NetMiko in that case. So unlike Napalm, NetMiko actually does not provide any CLI tools for the to start with. It's just an abstraction layer, and it often offers a like a Python method to connect with the device and then execute the CLI command itself. So just as an example, if you want to have a Python script where you want to connect with the Cisco device or a Juniper device or any other vendor, so this actually leverage you to connect with the device. So how the your program will look like you can have the library from NetMiko import connection handler. So this actually help you to handle the connection between your program and the device. So you have to then provide different parameter like the device type. In this case we have the Arista EOS and the host and username and the password as well. And then you need to send the command like show IP interfaces. So in this case we are actually we want to execute the command like we do over the CLI. Again, the more detail is available on the GitHub for this, like how you can configure the NetMiko proxy minion and use it. The Caprica is actually a tool which was initially designed by Google, and it was used to facilitate them or develop the different ACLs they want to implement on platform. And later on, initially it was like like only used within the Google, but later on they open up, and now it's an open source. And the Salt actually initially had this from the since the release of 2017.7.0. So this actually help us to simplify the use of integration with other tools as well. So in case of Caprica, how you can have your file, so you can have like salt device caprica.get and then term config. So this is a way like how you have to write your code, and then you can specify the source address, destination address, accept connection, and after that the ACL that you want to implement there. So let's next see how the salt CLI syntax look like. So we have, like earlier we saw how we can check the connectivity from the master to the minion. So like we can do a similar thing, like we can specify salt and then the device name, and then we can have the command like test-ping, which actually give us the output. Okay, we have the connectivity with this device or not, and it's available, the channel is open or not. So in case of like salt CLI syntax, we actually use the function and arguments. So function actually help us to execute different modules, and there are like number of modules you can use natively within the salt, and you can use them to do different things within your environment. So like in the previous case, we were actually using the test execution module and then using the ping function as well. Similarly, in other modules, you can have number of different functions which actually are already there. You do not need to write, and you can just leverage the usage of the existing function to complete your tasks. So again, the salt function, they return, they can return the JSON serialized data. That's mean any function return is could be similar to like a Python object. So in this case, when we execute salt router 1 test-ping, so it will give us not the latency like the traditional command we use. It will just give us like true or false. So if the connection is with the device is available or not, so it will give us the status only. So it's a way of to check the test the connectivity between the salt master and minion as well, and it is not a way to measure the latency between the devices. Again, the same we have here. We can, if we just want to have the raw output, we can use this switch dash dash out equal to raw. So in this case, it's actually give us the more detail for this output. So if we want to have like a function, multiple, these are the different functions that we can use against the devices like grain.item, pillar.item, config.item, sysdoc, and similarly you can give like multiple even functions, and you can get, if you want to just get specific thing, then you have to, here we are using a function and then passing the argument, like we want to get the serial number, so we are interested only for that. So as in the last example, we said like we are just interested to serial number, so that's mean it will return the serial number as a grain, and in this case the serial is just an argument, and which we are passing to the function, and then function can be executed with 0 or more arguments as well. It's not necessary to pass on, but in that case we will get the different output if we do not pass the argument. So in the previous example, the grain.item and pillar items, so they actually do not require any arguments, like we can see here grain item and pillar items, we are not specifying any arguments, we can execute them without specifying any arguments in that case. So this is again the example for salt CLI syntax, where we are specifying, okay, salt, then device name, then grains.get dash grains.get, and then we are specifying the argument as a version. So this will give us the detail according to our request. So it will give us the version which is running on this device as well. Similarly, we can specify, if we want to have the pillar data for the proxy, we can specify, okay, give us the detail about the leaf 1 device, which is in our case would be maybe a switch somewhere, and it will give us then the detail about that, what is the like the iOS host name, password, and the other details. So some of the functions in this case are the proxy minion specific, and they could be like very regular minion and proxy minion, and could be very different in nature as well, depending on the third party libraries and the program as well. So like here we have the Juno's proxy minion example, where we have salt router 1 Juno's facts, and we have the salt router 1 Juno CLI, and we are specifying some arguments here. So we have specified give us the show version. So it's similar like we are going to the device and then executing the command show version, or we want to get the inventory, then we in case of Juniper it's get chases inventory. But you cannot use the similar for the Cisco as well, because this is only supported in case of Juniper. So some of the commands could be like very proprietary, and then we are using the function for the Junos. So if we will execute with Cisco, it will not work. So we have to think about it, like some of the function could be very specific to a certain minion. So this is another example we have. In this case we have NetMiko proxy minion, and we want to get the show version. So in this case, because NetMiko actually it's supported against the multiple vendors, we do not need to worry about it, and then it can actually help us to give the output from the device. If we want to specify send the configuration, we can use the NetMiko send config, and we can use the command system NTP server. So this is similar, like you are going to the device and executing these command. Instead of that, you are writing within the netmiko and then using the salt CLI syntax to execute them. Again, we want to, if we want to use napalm proxy minion specific function, then we have these example to get that, and we can get like the ARP, like the MAC address. We want to see the roots. This is how we can do that. We want to check the NTP stats. We can execute ntp.stats. If you want to check the BGP neighbors, you can do the bgp.neighbors, again interfaces and environments as well. So depending on what you want to do using a specific function. So when we execute the salt CLI execute the command using the salt CLI syntax, so how we do that? We have the salt option, target, and then function and argument. So far we have only used the specific target like the router 1, but even we can be generic. Instead of specifying router 1, if we want to execute it against all the routers or all the server, we can also specify that. So in case we want to use it for multiple routers, this is how, using the comma, we can specify what is our target. And if you even want to execute for all of the router, then you can use like the asterisk router asterisk, then it will be just matching the routers and then executing this command against all of the routers as well. So these are the different like patterns we can use. We can use asterisk to match everything. Like in other program we can use like to match a single character like question mark. We can have a sequence, and we can match any character that's not in the sequence. We can specify in similar way. So like here we have the examples as well. You can see router asterisk would match with the router 1, 2, 3, 4 and so on. If you do not want to match with the router 2 and 3, you can you just want to match with the router 2, then you can specify not 2, and it will not match with the router 2 and match with the others as well. So whoever will be starting with the 2, that will not be matched in this case. You can use regular expression. In that case, you have to specify salt-e, like in case of grep command we use. Similar, we have the concept here. So this is again we are using the Perl compatible regular expression in this case, and we have to like write in the similar way. So this will match the router 1 and router 2, but if you want to have the match router 1 and router 2, router 11, 12, then you can specify like plus sign, and it will then match this second number only. So we can use the grains could also be used to selecting the groups. So then we have specified -G to select those grains, and then it will be selecting based on the role that we have set for the router. So in that case, the example is like salt-G, which is grain, and model MX960. So it will match Juniper 960 devices and then execute the command for those devices only. So another thing, like using the grains, we can target the grain using the PCR, and in that case we can specify -P and then the model and then MX, and in this case it's actually matching all the MX, whether it is 480 or 960 or 104. So it will match against all of the Juniper MX series devices. If you want to match against the specific version, so you can specify the version, but you just want to match the major version and not the minor release. So you can specify star. In that case, it will actually just check the major release and not the minor in this case. So in pillars, we have the data which we provide, and either this could be file and through external sources as well. So if we want to match that, we have to use the -I switch, and then it will match with the pillars as well. So this is another way, like similar to like the we want earlier use the minion ID and grain, and we can match any of the regular expression on the pillar data. Like we want to specify sol-j. In that case, it will go to the proxy host, and then it will match with it. It could be like your VMX1, VMX2. So it will be matching those based on this. Another is like the, if we want to have like more than the one criteria to target, like in this case we want to combine the previous target. So in this case we have the salt C, then the router, and we are specifying AND. So in that case we just do not want to execute based on the device, we want to check the vendor as well. So in the, we want to make sure it is the Cisco, and then the specific model and the specific version as well. So this will help us to be more specific about the certain devices and what is the iOS or the operating system they are running. Again, this is the example for the compound target. Like we want to specify the we specify -C in the option, and then within the expression we can select like multiple selectors to specify our need, what we want to achieve in this case. This is again the example for the compound target, and we can have like and or combination, because in case of and all the matches should be true. But if you want to have or, like either this version or this version, but the model vendor should be Cisco and the model should be NCS, then you can use the combination of or as well. So if in case the master configuration file, we can define specific groups for the common user target we have. So we can have the node group like the Junos router, we can have Cisco routers, we can have Arista, we can have Huawei. So that actually help us to combine these things based on the node groups we have. So then we can just select the one node group like salt-n node group and Junos router. So it will then be only executing those command on the Junos router only. So instead of specifying the multiple selectors, we can just select the node group. Similarly, we have the guide for this on the GitHub, which is the lab 4. If we are doing the lab, then in that case we can follow, but unfortunately we are not doing. So in case of salt, if you need help similar to others program, you can execute salt-help, and then it actually give you the help, and it will provide you the what are the different target option and the option of the command that you can use, and the output options as well. So you can display this using like output. You can print the output in one of the like available format, which is like JSON or YAML, or you can have the Python object, and you can have tables, and the default is like the YAML, which is the human readable and colorful format. So if we want to have the output in JSON format, so when we execute the command from the CLI like salt router net that ARP, so in that case I'm going to get the ARP from the router, and I want to have JSON format, so I have to specify it, otherwise it will not give in the same format. And even we can send the results to a specific file. We can specify output file, then it will write to the file, and we can have like output file, and you can specify the directory as well where you are going to write, and this will actually return the specific documentation and specific module to execute that function as well. So like we said, we can have the output in a specific way. We can have the logging available. So in case you need to know what is going on over the console, and you want to look into different things like errors or warnings or information messages, so you can specify the log level you want, and the default is the warning. Again, you can specify the path of the file where you want to send the logs. So that's mean you want to save the logs, and later on you can retrieve them when you want to check. So this is also available here. So the next is the salt configuration management, and yeah, I have to go to the lab. So in case of configuration management, we can also use the salt to do this on our behalf, and in this case we have like a different mechanism depending on the different library that we actually use to achieve this thing. And after we have uploaded our data, and then we can use the proxy module to actually use it. So in this case we have an example here how we can use the configuration management using napalm. So in that case you can see we have the different option, like we can have Junos SLS, iOS XR SLS. So these are the different pillar files that are actually there, which we can use to pinpoint the napalm. So if I need to like check and view the contents of Junos, then I can use this command, and it will give me what is the setting I have given within the file, because now I will use the napalm to interact with the Junos devices. So driver is like you need to specify the operating system on the other side. Host, here you have the option ID. This is the proxy minion ID you have for this device. You need to specify the username and the password. So based on this, it will be able to interact with the device. So then we can execute like the salt proxy ID and the router 1. So it will be able to interact with this device, and what are the different things we need to do, it can do there. If we need to specify like multiple devices to this is how we can specify the proxy ID and then the device name, and it will keep on like executing those. We can even specify multiple devices just in like same command, like router 1, core 1, spine 1, leaf 1, and then what is the command we need to execute. So it will give us the result like the leaf 1 is true, router true, and if any of the device is not available, it will give us like the false. So in case of napalm, we can actually load the configuration as a text from a specific file as well. If you have like you are going to install some of the devices and you have already prepared some configurations, so you can just load the configuration from that file and then use the napalm to execute that. Even you can use some of the templates which can actually help you to configure the device into a certain state as well. So you can see we can use the net.load config in dash case, and it has the different option available. So it will load the configuration from different files. This could be the specific absolute path for the file, or you can just specify the remote file which are like associated with this. So here we have the example where we are saying salt router 1, and it need to load the this text set system NTP, we are going to set the NTP setting for the server, and we have specified like test should be true and debug is also true. So in that case, it is going to execute this, and if it is already configured, it will show us the false, and then the configuration will be discarded, and it will show us the difference, what is it's actually going to add to the device, and then the command it has executed, and the result it will also show. So the return will be the number of elements we have. Like if we have already configured, then a boolean could be a state whether it's already configured or not, or changes has been made. The comments are like for the human standing, and diff is actually used to show the difference of the configuration, what is the difference between existing and the new configuration there. And at the end you will have the result which is telling you the execution was successful or not. Similarly, we can see here, we can now have even the configuration in the file, and then we can load it. So how we can do it, this is the way, like we can have salt, and then we can specify the file from where it need to load the configuration and then execute it. And after you have executed this command, this is the like the output could be. So in that case, it will show us the result was true, like it was able to load the configuration from the file, and it is able to apply as well. Similarly, we can see here the other examples we have. We are again loading the configuration from the iOS XR using, and then we have specified here the test should be true. In that case, it will apply the configuration and give us the result. So if you have a different platform, you can specify the separate templates for them, and then use it. So here we have the example, like for the salt router one, we want to use this Junos template, and in that case it will use that, because the previous one was for the Cisco. You can also have like a more flexibility if you want to execute based on the host names. You have a template against the host name, and then you can use that. So we have to specify, like in case of in the in template file hostname.jinja, and if the grain OS is equal to Junos, then set the system hostname and system ID and grain vendor, and if it is other than that, then we actually we are not mentioning the host name. We just want to have the host name and then the ID. So actually this is only applicable in case you have the Junos router. This is applicable in case you have the other OS. So you can also use even the same file, and within the file you can write the different like else if command or the structure to execute that, because the previously we discussed like how you can put up if and else statement and structure just to execute that, and when it matches a certain operating system, then it actually only execute the commands. So if we do that, this is an example like how it will do. So when it will going to execute that, so it will apply the else if, and it will match the, in that case, the operating system and the vendor as well. And if it matches, then only it execute the certain command. If it does not match, then it execute the else command. So this is the output for same, like we have seen here, the host, core 1 and plus. So minus sign shows us like this command is it's removed, and the new command has been this is the new command which has been added in this case. So we are updating the host name from core 1 to Cisco, because here we have specified the grain vendor. So whatever is the vendor, that is actually we are adding in the host name as well. So all the router, we will be able to update their host name based on this. Whatever is their vendor, the host name will be added. So if you have like maybe 10,000 devices and you want to execute update their host name, maybe you will end up doing this over a certain number of days. But by having this just code, you will be able to execute like within the few seconds or minutes as well. So you can also schedule the configuration, and you can revert the configuration as well. So we can specify here, like we can want to load this configuration, and then we want to commit in 2 minutes. That means it's not immediately executed. It will take 2 minutes, and then it will, after that it will apply, and it can revert it back as well. So after 2 minutes it has applied, it will revert because you have not committed those changes. So this is morely, maybe you have seen in case of iOS XR or Junos, this is even on CLI available. Because sometime you want to do some configuration and you are not sure what is going to be the impact of it. Maybe your own access to the device will be lost if that configuration does not work in the same way. So you have the option to roll back. But in like previously in classical devices, old devices, this feature was not available. But using this salt, you will be able to test it and get it back as well. You can use also the configuration management using the NetMiko as well. So here we also have the example for those, but due to the time I have to unfortunately stop here, and I would request you, if you can if you have any question you can ask, and meanwhile you can also fill the survey here. So it would be nice to have your feedback for this presentation. And please, if you have any question, you can ask.